Hi, my name is John, and I'll be going over conics today. Different types of figures that are broken up from two conics right there, two cones. And when we slice it in one certain direction, if it's perpendicular to the axis, it becomes a circle. If you cross a plane with it at an angle, it becomes an ellipse, noted right over here too as well. You slice it parallel to one of the cone edges called the lateral height, it becomes a parabola. You slice it parallel to one of the axis, it becomes a hyperbola. Hyperbolas are located right here. Notice that hyperbolas come out two different forms. Let me draw this for you nice and neat so you can see it a little bit better. It looks something like this. Okay, and these are parabolas. You've seen parabolas in Algebra 2. These are ellipses, and of course everybody knows what a circle is. It looks something like that. Okay, so let's get started with some of the information. I'm going to use a different pen if I can, because I don't like this one very much. So we'll use a sharper edge one. Okay. So let's get the next picture right over here. Oh, geez, who's that? We all know who that is. You kind of see a picture of him. Notice that right over here, it kind of looks like an ellipse. Okay. Whoops, like something like that. That's an ellipse right there. You got some circles right here. You got another ellipse right over here. Maybe a circle right here. If you go like this, whoops, then that becomes a hyperbola. So got his eyes too as well. So you can see that there's lots of different conics that can come out from certain cross sections of conics per se. Okay, so when you slice a plane through any one of these, it becomes a conic, and most books have nice figures of what conics are. So here's a nice little picture of an ellipse. We'll look at ellipse very detailed later on too as well. Okay, so we always start with the definition. I kind of made up my own definition. Wrestled a lot of time with this definition. A point is defined as, so if there's like three lines right here, 1, 2, 3, that means is defined as. You'll see this quite a bit when you go into like college and stuff. A point, I know that in geometry, the first three things that you've learned was the definition of a point, a line, and a plane does not exist. These are called the three undefined terms. I'll explain why they're called the three undefined terms. A point is defined as a singular entity in many dimensions or no dimensions at all that has no width, depth, or height, but can be represented in a plane by Cartesian coordinate system by x, y. What did I just say? I have no idea what I just said. So let's look at the Cartesian coordinate system, and here's a point x, y. If you blow this up, basically, it looks something like this. Notice it has a little bit of width, a little bit of height, and it has a little bit of depth because I actually pressed into the paper a little bit. But it has none of those qualities. It's an entity, a singular entity in many dimensions. This is in 2 dimensions. We could put a point in 3 dimensions or 4 dimensions, or no dimensions at all, which could be like a point. No dimensions, 0 dimensions is a point. You put it in 1 dimension, kind of like this, and here's a point. You're not actually supposed to see that point, but because we want to signify that there's a point there, we put a little circle with the circle wrapped onto it, something like that. So you get the point. Call it xy in the 2-dimensional space. Okay, and of course, same thing would happen with the plane as well. The plane would have no thickness. It actually has no thickness involved. This is a plane per se. We represent it as a plane, but you notice it has a little bit of thickness right over here. which it shouldn't have any. So let's get to the definition of a circle. A circle is defined as a locus of points called xy on a two-dimensional surface. It has two dimensions. It's usually on a two-dimensional surface called a plane, or a point called the center. We're going to signify the center point as h, k. This is extremely important. Let me take this out, underline it. So you have a center called h, k, and the locus of points x, y is always equidistant. In other words, the only thing you need to define a circle is a point and a line. I'm sorry, a point and a radius. Okay. So let's look at a circle. Everybody knows what a circle is. And let's try to create the equation of a circle. You can draw it this way. Here's your x-axis, here's your y-axis. We're going to call this, of course, by the definition, h, k. Located right there. And what happens is it's going to be on a point, a locus of points that are equidistant. From here to here, we call that the radius r. And then we use the, I'm going to do it just a little bit different than the way the book does it. Usually the book does it, because of the fact that the distance formula, most books use the distance formula. Distance formula is the Pythagorean theorem in disguise, so we're just going to use the Pythagorean theorem. By definition, there's a point on the circle called x, y. You have a radius r, and you have your center, of course. Okay, so these are the three things you need, but these two are the two crucial important things. Well, we know that this distance right here is x minus h, and we know that this distance right here is equal to y minus k. And so, using the Pythagorean theorem, x minus h quantity squared plus y minus k quantity squared is equal to r squared. This form is called standard form. Of course, if you have a standard form, then you should have a general form. We'll go over the general form a little bit later on. Okay. What else do we want to know about this? Oh yes. The second thing I want to go over was, in the case where your center is at the origin, so 0, 0, 0, 0, 0 is your origin, here's your x and here's your y direction, right over here. And on that point is called a point, on that circle is called a point called x, y. If you draw it out this way, notice right over here, from here to this point right here, from the origin to that point is x. This distance is y. So using the Pythagorean theorem, x squared plus y squared is equal to r squared. X squared plus y squared, oops, I have to put y right over. Excuse me, r. R stands for the radius, right? So we have two different circles, equations. This form, the second form, is a degenerate of located at the center instead of transformed to the right or up or whichever way. So this is actually a transformation of this original equation right over here. You notice if h is 0, k is 0, it degenerates to x squared plus y squared equals r squared. Okay. So let's get started on a couple of problems. I wrote them out for you, or in Microsoft Word, that is. Let's get example number 1. It says the point 1, 4 is on a circle whose center is at -2, -3. Write the standard form of the equation of the circle. First thing we want to know, here's my h and here's my k. I want to make a quick note. This equation seems to be a little bit difficult to memorize. So your center is at h, k. So what happens is the x goes with the h, y goes with the k. H before k, x before y, right? X comma y, x goes first, so it goes with the h, which comes before the letter k. So that's a good way to memorize it. Okay. So I always like to label these h comma k right there. I'm going to start writing the equation of the circle. Okay. So it's going to be x minus negative 2 squared plus y minus negative 3 quantity squared is equal to r squared. So, oops, let me move this just a little bit so you guys can see it. If we rewrite the inside, x plus 2 squared plus y plus 3 quantity squared is equal to r squared. I'm going to say this once, twice, maybe 3 times. Find your center first. That's the most important thing in all the conics. So find your center in life. Everything revolves around it. Again, the center is the most important thing, so always find your center first in most of these conics. So that's what we have so far, equals r squared. Let's actually draw it out. Negative 2 and negative 3. 1, 2, 3. And the point 1 comma 4 is on it. 1, 1, 2, 3, 4. To find this distance r, I'm going to use a little bit a nicer marker right here, bigger marker. To find that r, you can, the book does it just a little bit differently than the way I'm going to do it. I'm just going to put, there's your coordinate x comma y, and there's your center, h comma k. I'm just going to put in 1 for my x and 4 for my y. We have to figure out what the radius is. So working that out, you get 3 squared plus 4 plus 3, 7 squared is equal to r squared. That's 9 plus 49 is equal to r squared. 58, r squared is equal to 58. Of course, the radius now becomes the square root of 58 because you take the square root of both sides. So the equation actually becomes, from this equation, x plus 2 squared plus y plus 3 squared is equal to, we have to square this again, that becomes 58. And some of you are saying, wait a second, we square rooted it and then we squared it back, so you didn't actually have to square root it. Okay, so make sure once you solve for r squared, which is 58, we just plug it into the equation. The standard form for the equation again is x minus h squared plus y minus k squared is equal to r squared. Okay. Let's do example number. So actually, this circle should look something like this. Okay, so I'm going to go out of the page a little bit, but I really don't care what the circle looks like. It's just, here's the center and here's a point on the circle. Okay. Next question that I'm going to do, example number 2, is sketch the circle given by the equation. So it's going to take a little bit of space, so here I'm going to rewrite it really nice and neat. X squared minus 6x plus y squared minus 2y